All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about electric field intensity. So, right, the electric field intensity or strength at any point in a field is the force per unit charge at that point. All right, so the electric field intensity simply means the force per unit charge of that particular point. Right, so now, right, the direction of the field strength. The direction of the field strength is that of the force on a positive charge. Thus, electric field intensity is a vector, right? So you should know that electric field intensity is a vector. Apart from that, you should know that electric field intensity is simply force per unit charge. That is force over charge, all right? And it's measured in what? Don't forget that force is measured in Newton, and then charge is measured in Coulomb. So it is measured in what? Newton per Coulomb, right? So now, you need to equally know that electric field intensity. Okay, before that, you don't forget the formula for your force. Okay, the force of attraction or repulsion between two charges. Don't forget that it is equal to what? K q q1 q2 all over what? R squared. So which is still the same thing. Now don't forget that the value of K is 1 over, so this is what? Q1 q2 all over what? All over okay, let's assume that q1 and q2 are equal. So I'll have that q squared all over what? 4 pi e naught. All right, r squared. Don't forget that this 4 pi e naught is same as that k is same as 1 over 4 pi e naught. All right, so if you now put this thing here, you will now see that electric field intensity is equal to, instead of putting force, I'll put this one, q squared all over what? 4 pi e naught r squared. Then don't forget that there is a q here. So if this take care of this, if one of these q take care of one of these q, I'm having that electric field intensity is q all over what? 4 pi e naught r squared. All right, or you say that it is what? Kq over what? R squared. So this is formula for electric field intensity. All right, so another formula you need to know about electric field intensity is that electric field intensity is the change in flux, okay, over what? The change in area. Change in flux over change in area. So you don't forget that this file means what? Electric flux. Electric flux. All right. So then where your A is your area. A is your area. So that is the second formula for electric field intensity. Another formula for electric field intensity is that electric field intensity is what? Potential difference all over distance. Okay, the rate of potential difference to the distance. So you have potential difference V all over what? The distance. So you can have that this is what? Where V is equal to potential difference all over what? The distance. So if you remember that potential difference is measured in volts and distance is measured in meter. So volt per meter is what? Is another SI unit of electric field intensity. And then finally, electric field intensity is what? The negative grad V. Negative grad V. Don't forget, where V is still what? Your potential difference or electric potential. So that is that. So we will be solving some questions to illustrate what we have just said. So let's take the first question. The first question here said that the potential difference across a parallel plate, all right, capacitor is 10 raised to power 3 volts. Okay, then I say if the distance between the two plates, okay, between the two plates is 10 cm, comma, then calculate the magnitude of the electric field intensity or strength, electric field strength between them. Solution, right? Now, what do? The first thing you do is to bring out your parameter. They gave me volt, the potential difference, which is what? 10 raised power 3, 10 raised power 3 what? Volt. All right. The next thing they gave me is the distance, which is what? 10 cm. But I have to change it to meter, which is what? 10 divided by 100, which is 0.1 meters. All right. So what do you have now? You now tell them what? Electric field strength or intensity is simply volt over what? Over the distance, which is what? 10 raised power 3 divided by 0.1. So which will give you what? Which will give you 10 raised to power 4. 10 raised to power 4 in what? In meter per coulomb. Sorry, in meter, in volts. Volt per what? Volt per meter. Volt per meter. Okay? So that is that. Let's take the second question. This is very simple. So let's take the second question. Number 2. Number 2 said an oil drop carrying a charge of 1.0 times 10 raised power minus 19 coulomb is found to remain at rest in a uniform electric field intensity 1200 Newton per coulomb. Then they now say calculate the weight of the oil drop. All right. So solution. Now, the first thing they gave us is the electric field strength or electric field intensity E, which is 1200 Newton per coulomb. Please always learn how to bring out your parameters. So the next thing they gave us is charge. Charge is what? 1.0 times 10 raised power minus 19 coulomb. So, but we know that what? And they say we are looking for what? Weight. Weight is measured in Newton, and the force is equally measured in Newton. So they're equally asking us force. So what do we have? We have that E is equal to what? The force per unit charge. Don't forget. Force per unit charge. So what do I have here? So to get my force, I'll have that what? Q times my E. Okay, which is what? What is my Q? My Q is 1.0 times 10 raised power minus 19. Okay, then times my electric field intensity 1200. That is my E. 1200. So if you multiply that, you will be having 1.2 times 10 raised power minus 16 in what? In Newton. So that is my weight. This is the weight. All right, very simple. So we'll move to the next question. So number 3 said a charge of 2.0 times 10 raised power minus 5 coulomb experiences a force of 80 Newton in a uniform electric field. Calculate the magnitude of the electric field intensity. These are very simple questions. So the first thing you do is to bring out your parameters. They gave us charge, and the charge they gave me is 1.0 times 10 raised power minus 5 coulomb. All right. So the next thing they gave me is force. They gave me that the force is 80 Newton. And I know that my electric field intensity or strength is what? The force per what? Per charge, which is what? That is Newton per coulomb. So what do I have? My force is 80 divided by 2.0 times 10 raised power minus 5. So if you divide that, you'll be having 4.0 times 10 raised power 6 Newton per what? Per coulomb. Newton per coulomb. This is very simple. We are still solving the simple one. We are getting to the more complex ones, right? Though all of them are very simple. So the next thing we move to is number 3. Number 3 question said, what is the electric field intensity in air at a distance of 47 cm from a charge of 6.0 times 10 raised power minus 7 coulomb. Okay, they say if the force on the charge is 3 times 10 raised power minus 4 Newton. Solution. Okay, so they gave me distance. Okay, they gave me the distance as what? 47 cm, which is what? 47 divided by 100, which is what? 0.47 meters. Okay, the next thing they gave me is charge. The charge is 6.0 times 10 raised power what? Minus 7 coulomb. The next thing they gave me is force, which is 3.0 times 10 raised power what? Minus 4 Newton. So, but I know that my electric field strength is what? Force over charge. So I don't need the distance. So what do I have? 3.0 times 10 raised power minus 4 divided by 6.0 times 10 raised power minus 7. So if you do that, you're going to be having 5.0 times 10 raised power 2 Newton per coulomb. Okay? Very, very simple. So we move to the next question. And the next question here said that the force, number 4, the force between two identical charges P and Q is 4.2 times 10 raised power minus 2 Newton. They say if the magnitude of each charge is 2 μ coulomb, all right, comma, they say calculate the electric field due to P at the point where Q is situated. All right, this is very, very simple. So solution, bring out your parameters. The first thing they gave us is force. The force is 4.2 times 10 raised power minus 2 Newton. And the next thing they gave us is charge. The charge they gave us is 2 μ coulomb. And what is μ? That is 2.0 times 10 raised power minus 6. Please, μ means 10 raised power minus 6. There you put your coulomb. So I know my electric field intensity is equal to what? The force per unit charge. What do I have? 4.2 times 10 raised power minus 2 divided by 2.0 times 10 raised power what? Minus 6. So what do I have? I'm having a 2.1 times 10 raised to power 4 what? Newton per coulomb. All right. If you don't want to have it in Newton per coulomb, don't forget it can be written as what? Volt per meter. Depending on the SI unit you want, but they are the same. You can check according to the option. Right? So let's take the next question. We are moving. The next question here said when two charges when two charge carriers, separated at a distance of 3.2 times 10 raised power minus 3 meter apart, all right, in vacuum. In vacuum, are allowed to move under their interactive electrostatic force, comma, one with mass m1, which is equal to 6.3 times 10 raised to power minus 7 kg. Okay, start with an acceleration 8 meter per second, right? Then I say while the other with a mass of m2 starts with an acceleration of 9 meter per second square. Where is the other acceleration? Per second square, sorry. Per second square. Then I say calculate the charge and mass of the second carrier. Okay? This is carriers. All right. So what do we do? Solution. Now, if you look at this question, they said when two charge carriers separated by a distance, they gave us distance. Let's say that r is their distance, which is what? 3.2 times 10 raised to power minus 3 meter. This is their distance apart, okay? In vacuum, are allowed to move under their interactive electrostatic force. Okay, now I hope you know that they are moving with one force. The force they are moving with is the same, because that is either force of attraction or force of repulsion. Okay, but since they are talking about their mass, it is not in terms of their mass, it is the force of attraction. Don't forget that in gravitational in gravitation, okay, we have only force of attraction, but in charges we have either attraction or repulsion because of different in charges. We have, when they are the same charge, they repel, but if they have different charge, they attract. So now they have the same force of attraction. So from the mass they gave me here, they said that the mass m1 is equal to 6.3 times 10 raised to power what? Minus 7 kg. All right, and then they gave me that this one is moving with an acceleration of 8 meter per second square. But I know that force is equal to MA. Is it not true? Force is equal to MA. So how do I get that now? So the force they are using to move is what? 6.3 times 10 raised to power minus 7 times 8. All right. So if you multiply that, you are going to have 5.04 times 10 raised to power minus 6 Newton. So this is the force that they are moving with. So we are asked to calculate the mass of the other man. If you want to get the mass of the other man, we will tell them that again, that force is equal to what? MA. So we will now use M2A. All right. Let's see, we use M1 here. So this is for F1 and this is for F2. Okay. Let me say M1 A1, M2 A2. But you need to know that F1 must be equal to F2. All right. So if I now put it, I'm having that 5.04 times 10 raised to power minus 6 is equal to what? M2 I'm looking for times A2 they gave us as it was moving with 9 meter per second square. All right. This one was moving at 9 meter per second square. So if you now put it here, 9. So therefore my M2 will now be 5.04 times 10 raised to power minus 6 divided by 9. So if I have my M2, if I divide it, I'll be getting I don't have calculator here, so let me just be using the one I've already solved. So if you divide that, you're going to have 5.6 times 10 raised to power minus 7 kg. All right, so that is that. So now the next thing they say we should calculate is the charge. The charge. Okay, how do you calculate the charge? Two charge carriers. If you want to calculate the charge, you will not know that what since we have that what, don't forget that force is equal to what, k q1 q2 all over what, r squared. Okay, so but here q1 and q2 are equally the same. Q1 and q2 are equally the same. All right, they have similar charge. So since q1 and q2 are equally the same, I'll have that what, f is equal to what, kq squared all over what, r squared. So don't forget that your k is a constant, which is what, 9.0 times 10 raised to power what, 9 is always 999. So that is how to remember it. So if you now do that, you have that that I want to make q squared subject. So if you cross multiply this, we go here, I have that q squared is equal to what, fr2 divided by k. All right, so if you now put it, my f, I've gotten my f to be, where is my f? This is my force, I've gotten it. This is 5.04 times 10 raised to power what, minus 6 times the distance apart is what, is 3.2 times 10 raised to power minus 3 all squared, then divided by my k is what, 9.0 times 10 raised to power what, 9. So if you solve that, if you press your calculator, you will be having so my q squared is equal to whatever you get here, then my q will now be the square root of whatever you get here, then that is my q. So use your calculator and punch. Okay, punch this times itself again, then divided by this, you get it, then do the square root, you get the final answer for the charge. All right, so tell me what your answer is at the comment section. Let's know if you know how to punch calculator. Yes. So the next question, we move. The next question, question number 9, said if an electron is driven by an electric field of strength, the strength E is equal to 4.8 times 10 raised to power minus 4 volts per meter. I told that I can use any SI unit they like. Volts per meter. They now say calculate I question the force on the electron. Okay, I. They say calculate the acceleration of the electron. I. They say we should calculate the distance moved by the electron. Distance moved by the electron under this field. In the first 2 seconds. Okay, they now say we should take that the mass of electron, is equal to 9.1 times 10 raised to power minus 31 kg. All right, okay, all right. So now from here, what do we do? Solution. The first thing they say we should calculate is the force on the electron. The force on the electron. But I know that electric field intensity is equal to what? Force per unit charge. Okay, force per unit charge. And what is the charge of electron? Yes, don't forget that the charge of electron, they're supposed to give it to you, but if they don't give it to you, you need to know that the charge of electron is a constant and is equal to 1.6 times 10 raised to power what? Minus 19, okay, coulomb. Please correct. In my first video I made mistake, I used I think minus 12. Okay, please correct that. is minus 19. Okay, so that is that. So if we want to get our force will now be what? The charge times the electric field intensity, which is what? 1.6 times 10 raised to power minus 19 times, they gave us the electric field intensity as 4.8 times 10 raised to power minus 4. So if you multiply that, you are going to have that the force is what? 7.68 times 10 raised to power what? Minus 23 Newton. Okay, so that is the force I. So let's solve the II. That say we should calculate the acceleration. You want to calculate the acceleration, you should never forget that what? That force is equal to what? MA. So my A will now be what? F over M, which is what? What's my force? I've gotten it as 7.68 times 10 raised to power what? Minus 23 divided by the mass of an electron is what? 9.1 times 10 raised to power minus 31. All right. So if you do that, if you divide that, you're going to have that the acceleration is 8.4 times 10 raised to power 7 meter per second square. All right. Now the next thing they say we should calculate is the distance. Okay, if you want to calculate the distance after 2 seconds, you can check your equations of motion that say that what? Don't forget, v is equal to u plus at. There is no distance here. V squared is equal to u squared plus 2as. There is a distance here, s, but there is no final velocity here. All right. So the one we're going to use is that what? S is equal to, let's use that one. S is equal to what? Ut plus what? Half at squared. All right. So that is the distance. So the distance S is equal to initial velocity here is 0. Okay. So 0 times the time they gave me is 2 plus 1 over 2 times the acceleration. I've gotten the acceleration as 8.4 times 10 raised to power what? 7. Then times my t is what? 2 squared. So if you have that, 0 times this is gone. 2 will take care of this. I'm going to have 8.4 times 10 raised to power 7 times 4, then divided by 2. So if you do that, you are going to have 1.68 times 10 raised to power 8 meters. So that is that for the distance. Okay. So you see, this is very, very simple. We move to the next question. And the next question here said that if a potential field, V, okay, varies in space x, y, z, as V is equal to 2x squared yz cube plus 3xy cube z squared. All right, this is what they gave us. Okay, they now said number 1, obtain an expression for the electric field strength E. Okay. All right. So number 2, they say we should equally calculate such electric field strength explicit at x, y, z equals 1, minus 1, 2. Okay, this is a very simple question solution. Now what do? Don't forget that what? That electric field strength is equal to what? Minus grad V. So let us do that, which is what? Minus, what is your grad? Your grad is what? Partial x, you put I, plus partial y, you put j. If you can remember your first semester vector analysis, plus partial zk. So if you have not watched my video on vector analysis, you need to watch it to understand it very well. So it's being multiplied, and don't forget it's a dot product. The dot product of grad and the V, and V they gave me there is what? V they gave me there is 2x squared yz cubed plus 3xy cubed z squared. All right. So now, and don't forget that this is okay. This is a scalar multiplying a vector. All right. When a scalar multiplies a vector, it gives us back a vector. So this now times this. Watch. This one times this means we are going to differentiate this thing with respect to x. We are differentiating this thing now with respect to x. So I have my minus in bracket of, now this times this one means we are differentiating this thing with respect to x. So anywhere we are differentiating only x. And if we did not see x there, it means a constant. So if you differentiate x, you have multiply by the power and remove 1 from the power. So I have 4x. If you remove 1, it's x raised to power 1. Then you attach your y z cubed because they are all constant. Plus differentiation of x here is 1. So 1 times everybody is the same. 3y 3 z squared. All right. I put my I am done using this, multiplying this. So use this to multiply the next person means we are differentiating with respect to y. So you have plus, open bracket again. Differentiate this one with respect to y. I will have 2x squared z cubed plus, differentiate this one, 3 times 3, 9. 9x y squared z squared. You put your j plus, this times the last one means, this times these people again means I'm differentiating with respect to z. So I open bracket again. 2 times this is what? 6x squared y z squared plus 2 times this is 6. 6x y cubed z. All right. I put my k and close my bracket. So that is the expression. That is the expression. Okay. That is the expression we are asked to find. So the next thing they say we should find is at this point. We need to get it at this point. So what do we mean by getting it at this point? It means then at point 1 comma minus 1 comma 2 means minus into 4 bracket 1, okay, bracket what, minus 1 bracket 2 raised to power 3, okay. You put your what, your I plus, you go again, 2 bracket 1 squared bracket 2 cube, okay, plus, sorry, I did not get that. You have to be very, very careful. You have to be very, very careful. So I have minus into, let's tackle here first. 4 into 1 into minus 1, then into 2 raised to power 3, plus 3 into 3 into minus 1, then into 2 raised to power 2. Then everything here, I'm putting my I to it. All right. Let me have this as the biggest bracket. Okay. Then plus, let's go for J now. I have 2 into 1 squared into 2 cubed plus 9 into 1 into minus 1 squared, then into 2 raised to power 2. You close and put your J, okay? Then plus, you have to be very, very careful. Plus, then for your K, I have 6 into 1 squared into minus 1, okay? Then into 2 squared plus 6 into 1 into minus 1 cube, then into 2. Then you close and put your K, then you now close with your big bracket. So to get the last answer now, I still have my negative with my big bracket. So what do I have here? If you do everything here, you're going to have, this is 8. 8 times, let me use my calculator. 8 times 4, 8 times 4, then times 1. 8 times 4, okay? 8 times 4, That is 32 times minus 1 to give you minus 32 here. And I have here as 4 times 3 is 12. 12 times minus this is minus 12. So minus 32 minus 12 will give you minus 44. So I have minus 44i. Okay. Now let's do the same thing here again. For here, I have that this is 8. 8 times 2 is 16. But what I have here is 4. 4 times 9. 9 times 36. So this is 36. And that is minus 36. So what I have here is so I have here to be minus 36. But what I have here is 16. So I have minus 36. 16 minus 36. So I have 20. Am I making any mistake anywhere? 8 times 2, 16. Yeah, 16 minus 36, that is 20. So I have minus 20j. Okay, so let's do the same thing here. For this side, I have minus 1 times 12. Here is minus 12. Here is 4 times 6 is 24. 24 times minus 1 is minus 24. So minus 24 minus 12 minus 24 minus 12 will give you minus 36. Minus 36k. So if you now multiply by the minus outside, I will now have minus times this 44i, okay, minus what? 20j, then minus 36k. So that is my electric field strength. All right. So I think they added some question there. Let me clean this, please. Write. You can pause the video and write. Let me add some questions that I think they added. That is question number 3. Question number 3 there they added was let me check. Okay, they can ask you to calculate the magnitude of the electric field strength. Okay, this is my E that I've gotten. This is my E. So they can ask you to get the magnitude. So the magnitude of the electric field strength, you see that electric field strength is a vector. That is why we have this IJK. So, but to calculate the magnitude, don't forget that magnitude of a vector is what? The square root of 44 all squared plus minus 20 all squared plus minus 36 all squared. Okay, so this is the magnitude of that. If you do that, you're going to be getting 77.05, right? In what? In, I think, Newton per coulomb, right? In Newton per coulomb. That is the magnitude. That is the size. If you want to get the magnitude of the electric field strength, right? So the next thing they say we should calculate is the okay, they said here, number 3, if the charge Q is equal to 4.0 times 10 raised to power minus 2 coulomb, okay, calculate the force on the charge. Calculate the force on the charge, comma, also calculate the magnitude of the force. Okay, calculate the force and the magnitude of the force. So question number 3, let us solution to question number 3. So what do? We know that electric field strength is equal to what? Force per unit charge. So what do? So therefore my force should be what? The charge times the electric field strength. So what do? So the charge there is what? 4.0 times 10 raised to power minus 2, which is even 0.02. Then times my electric field strength is this one. I'm not using the magnitude yet. Is this one, which is what? 44i minus, is it minus? So minus, sorry, plus here and plus. Sorry. Minus times this is plus this. Minus times this is plus. So plus 20j plus 36k. Alright. So this time this is simply, so this one is the same as 0.04. That is 1, 2. Yeah, 0.04 times all these people. Times 44i plus 20j plus 36k. Alright. So you can use this 0 times 44 and clear the bracket. So if I clear the bracket, I'll be having 44 times 0.4. 44 times 0.4. So I have 17.6 I, all right? 20 times that, 0.04 times 44. Okay, sorry, 1.7. Sorry, 1.76 I, all right? I have 20 plus 0.8 J plus 36, 1.04 K. Okay, so this is my force. So then another thing they asked us to find is the magnitude of the force. And don't forget that the magnitude of this force, the magnitude of the force is now the square root of 1.76 all squared plus 0.8 all squared plus 1.04 all squared. So covered with square root. So do that with your calculator and then you get your answer. So the magnitude of the force is going to give us 308 in what? In Newton. So that is that. Okay, I hope you understand that. You can watch the video the second time. All right, so the next question, we move. Yes, we move to the next question. And the next question here said, if a charge Q, which is equal to 1.4 times 10 raised to power minus 2 coulomb, is placed at position x, y, z, which is equal to 1, minus 2, minus 1, okay, in an electrostatic potential field, okay, an electrostatic potential field given as V is equal to 4x raised to power 3y z raised to power 5. Then they now say calculate the force. Calculate the force on the charge. Calculate the force on the charge. Another very simple question. So what do? Before you calculate the force, you need to calculate the electric field strength. Okay, so I know that my E is equal to negative grad V. Don't forget, please. What do I have? Minus into, what is your grad? Your grad is partial x, you put I, plus partial y, you put J, plus partial z, you put K. You are being multiplied by your V. What is your V? 4x raised to power 3y z raised to power 5. Okay, so now minus into this one now times this means differentiating with respect to x. So x is this, 3 times this is what? 12x, remove 1 here, 12x squared y z raised to power 5. Okay, you put your what? I plus this one into this means differentiate with respect to y. So and y is just 1. Differentiation of y here is 1. So 1 times everything is the same, 4x raised to power 3 z 5. Okay, so because differentiation of this has turned to, okay, you put your what? You put your J, okay, then plus differentiate with respect to Z. So 5 times this is 20 x raised to power 3 y, then Z raised to power 4. Okay, so this is my electric field strength. Then at that point, at point 1, minus 2, minus 1 is simply to put your value. So I have what? Minus into 12 bracket 1 squared into minus 1, then into minus 2, then into minus 1 raised to power 5. We put our I, the big bracket. You have to be very careful. Okay, plus the next person here is what? 4 into 1 raised to power 3, then into minus 1 raised to power 5. Okay, you put your J, then plus what? 20 into 1 raised to power 3 into minus 2, then into minus 1 raised to power 4. You put your what? Your K, then you close with your big bracket. So let me continue writing from here. So if you do this, you're going to have 1 raised minus 1 raised power 5 is still minus 1. Minus 1 times minus 2 is plus 2. Plus 2 times this will give you 24. So I have minus into 24i. Okay. Then come to this place. Minus raised power, this is minus. Minus times this will give you minus 4j. Okay. So here is minus raised power even number. The minus is gone. So I have minus 40k, minus 40k. All right. So if you now open the bracket with your minus, you'll be having minus 24i plus what? 4j, then plus 40k. So this is my electric field strength. Then if you are asked to get the magnitude, I hope you still remember how to get the magnitude. Then the next thing we need to get is the force. So but I know that my electric field strength is equal to what? Force over charge. Over charge. So my force will now be what? The charge times what? The electric field strength, which is what? The charge is 1.4 times 10 raised power minus 2 times my minus 24i plus 4j plus 40k. So if you now, this thing is set as saying 0.014. 0.014 times minus 24i plus 4j, then plus 40k. So if you open this bracket, you are going to be having 24 times that, 0.014 times 24. So I have minus minus 0.336i, okay, plus 0.056j, then plus 0.056k. So that is my force. But if you are asked to calculate the magnitude of the force, you still know how to get magnitude of the force. All right. So let me check my time. Oh, we are going to stop here. In our next video, we continue with a topic called electric potential. Electric potential. So thank you very much for watching. Please subscribe, like, and comment. Bye bye.